Newton's first law, known as the law of inertia, states that objects will remain at rest or continue moving in a straight line at a constant velocity unless acted upon by an external force. Inertia, the tendency of objects to resist changes in their state of motion, is a key concept introduced by this law. Objects with more mass have greater inertia and are harder to move or stop compared to objects with less mass. Newton's first law applies universally to all objects, regardless of size, shape, or composition. Understanding this law is crucial for engineers designing systems where motion needs to be controlled, such as in car safety features, amusement park rides, or space exploration vehicles. This law also has implications in fields like astronomy, where it helps us understand the motion of celestial bodies and predict their behavior in the absence of external forces. It establishes the concept of an inertial reference frame, where no net external forces act on an object. Objects in an inertial reference frame will maintain their state of motion unless acted upon by an external force. This law explains phenomena such as why objects at rest stay at rest and why moving objects continue moving unless acted upon by a force. For example, when you're riding in a car that suddenly accelerates, you feel pushed back into your seat because your body tends to resist changes in motion due to inertia. Similarly, when the car stops suddenly, you lurch forward because your body wants to keep moving forward at the same speed as the car, again due to inertia. In everyday situations, we often observe Newton's first law in action, such as when objects slide across a table when it's suddenly jerked or when water in a spinning bucket stays level due to its inertia. This law helps explain why astronauts experience weightlessness in space. Because there's no gravity or air resistance to provide external forces, objects continue moving in a straight line at a constant velocity. Newton's first law also explains why it's harder to stop a fully loaded truck compared to a bicycle. The truck has more mass and thus more inertia, requiring a greater force to change its motion. It underpins our understanding of motion in various scenarios, from the movement of planets to the behavior of everyday objects. In the absence of external forces, objects in space continue moving at a constant velocity indefinitely. Understanding Newton's first law is crucial for engineering applications where motion needs to be controlled and predicted. Mastery of this law is fundamental for deeper exploration into the principles of dynamics and the interplay of forces. It prompts philosophical reflections on the nature of motion and the principles underlying the physical world. Newton's first law serves as the foundation for further studies in physics and engineering. Mastering this law develops critical thinking skills and analytical abilities applicable across scientific disciplines. It encourages contemplation on the relationship between observation, theory, and the role of scientific inquiry. Newton's first law forms the foundation for understanding the behavior of objects in the absence of external influences and is the starting point for comprehending the other two laws of motion. Newton's first law highlights the concept of inertia and underscores the idea that objects require forces to change their motion, whether that's starting, stopping, or changing direction. By understanding and applying Newton's first law, we gain insights into the behavior of objects and phenomena encountered in everyday life, fostering curiosity and scientific inquiry. This law invites contemplation on the relationship between observation and theory, as well as the role of scientific inquiry in uncovering the mysteries of nature. Overall, it encourages individuals to ponder questions about causality, the nature of forces, and the inherent orderliness of the universe. Bible reference, Ecclesiastes 3:1. There is a time for everything, and a season for every activity under the heavens. This verse can be integrated into teaching Newton's first law by discussing how objects naturally maintain their state of motion unless acted upon by an external force, reflecting the idea that there is a natural tendency for things to remain as they are until something changes their condition.